Now we are still on unit number 7. We are doing probability and we started with lesson number 27. Today we are doing lesson number 28. And last time we were doing the expression of probability. So now we are looking at prediction of probability. The probability of an event taking place is a value we use to predict certain situations. However, we have no guarantee that this event will happen. For example, we can predict that a coin will land on tails when tossed in the air, but in reality, for example, it may land on heads instead. We can predict that there is a 40% chance of rain, but it may not necessarily be the case. So let's look at theoretical probability. They say theoretical probability is the calculated probability of an event and not the real outcome. Expressed as a number between 1 and 0, as mentioned at the start of this unit, which is lesson number 27. Probabilities can be written as fractions, decimals, or percentage. The formula used to find the theoretical probability of the event is PE. Remember, I told you that some textbooks, they use PE. So this is theoretical probability. PE is equals to NE over NS. Still the same, where NE refers to the number of the outcomes in the event, and NS refers to the total number of possible outcome. So NE is still the favorable outcome, the outcome that you want. How many are they? And NS is the total number of possible outcomes. When the total number of possible outcomes of an experiment has an equal chance of occurring, it is possible to calculate the theoretical probability of an event. A coin toss, for example, has two possible outcomes, heads or tails. Therefore, NS is equal to 2. If the coin lands on heads, the number of outcomes in the event is 1. Okay, because we can only have one head. We have already gone through this. Okay, so now let's look at the relative frequency. Relative frequency, the number of times an experiment, relative frequency is the number of times an experiment or event will produce specific outcome compared to the number of times the experiment is done. Okay, let's read it again. The number of times an event will produce to a specific outcome compared to the number of times the experiment is done. That is the relative frequency. If you flip a coin 20 times and record the results every time, according to the results, the coin landed on heads 12 times out of 20. So it means that the relative frequency of a coin landing on heads is 12 over 20, and the relative frequency of it landing on tails is gonna be 8 over 20. How do we get 8? Because we know that we got heads 12 out of 20 times, which means the remaining part, which is 8, it is the tails. Okay, so that is the relative frequency, the number of times for favorable outcomes, okay, compared to the number of times the experiment is done. Okay, so let's do, okay, so we just go straight to the activity with this one. Okay, so we have activity number 29, and this one you can answer activity number 29. It's not a problem, but I will continue with my lesson. Okay, now lesson number 29, methods of finding possible outcomes. Okay, and we can use tree diagrams. Remember, I spoke about tree diagrams. This is what you will use, especially if you've got more than one experiment. So a tree diagram is a useful method to predict all possible outcomes of an event or combination of events. Each branch in a tree diagram represents a possible outcome. Now let's look at flipping a coin. If we flip a coin 3 times, you see now we are doing an experiment 3 times. Okay, so tree diagrams, they normally work where we do the experiment more than 1 times. Okay, so we flip the coin 3 times in a row. The tree diagram will show the following. Okay, let's see this. Okay, let me minimize it so that it can fit the screen. Okay, so this one is our first throw, so we can get either heads or tail. Okay, heads or tail. And now we get the second throw. The second throw will come and attach it to the first outcomes. Okay, so this is the second throw, this is the second throw. Okay, so we can either get head or tails, or we can get head or tails. And because we already have 4 outcomes here, the third throw now it's going to be attached to all the 4 outcomes. So this is the third throw on this outcome, the throw on this outcome, the throw on this outcome, and the throw on this outcome. But it does not mean that we throw 4 times. It's just one throw, it's one throw, and it's one throw. Okay, so for the third throw, still we can get head or tails. We can still get head or tails. We can still get head or tails. We can still get head or tails. So now our outcomes, these are our outcomes that are possible. So for the first one, it's head, head, head. There it is. Second one on this one, still it's head, tail, head. No. Okay, so the first one is head, head, head. There it is. Second one, head, head, tail. There it is. And then we come here. We have head, tail, head. We have head, tail, tail. There it is. Okay, and we have tail, head, head. Tail, head, head. And we have tail, head, tail. There it is. You see? And we have tail, tail, head, tail, tail, head, and we have tail, 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 tail. So at the end of the day, we have how many outcomes? 2, 4, 6, 8. So for throwing the coin 3 times, we have 8 possible outcomes. Okay, so it's 1 times 2 times 4. So we have 8 outcomes. So now let's look. There are 8 outcomes. The probability of landing on heads 3 times. Okay, so head 3 times. Let's look at our diagram. I will minimize it again. Head 3 times. We only have head 3 times here once. Okay, so it's going to be 1/8. Okay, and the second question, the probability of landing on tails twice and on head once. Tail twice and head once. Okay, tail once, no, that's not the one. Tail once, no. Tail twice, yes, 1. And no, yes, 2 and 3. Okay, so it's 3, so it's going to be 3/8. 3/8. You see that? Okay, and now let's look at a different one where we've got different or we've got more than one experiment as well. So we have balls in a bag. There are red balls, white balls, and blue balls in the bag. What is the probability of removing a blue first and then a white bag from the ball? So you can see that there are 2 events here in number A. There's blue first and there is a white first. Okay, so 2 draws. So we will start by drawing our tree diagram, sorry. Okay, so when we draw for the first time, okay, we can only pick up blue, white, and red. Okay, and then we draw for the second time. This is the second draw, but each and every first outcome must have the second draw. So blue, white, red, blue, white, red, blue, white, and red at the end there. You see? And then we write our possible outcomes. It's blue, blue, it's blue, white, it's blue, red. That's it. And then we have the second one, white, blue, white, blue, white, white, and we have white, red. Okay. And the third outcome is red, blue, it's red, white, and it's red, red. So how many outcomes do we have? We have a 3, 6, 9 outcomes. So it's 3 times, sorry, yes, it's 3 times 3. So we have 9 outcomes. So let us see the questions now. The probability of removing blue first and then white. So blue first and white, it's 1/9. You see that? And then a probability of removing a white ball twice. We have white, white. So it's 1/9 as well. Probability of removing either a red or a white ball. Red or white, red or white. Here we don't have red or white. Yes, we have red or white here. Okay, and we also have red or white here. So it's 2/9. Let's see number C. Yes, that is the probability. So you can express it in percentage. Then you can use your scale. So you see, what do we do when we have a more than one event? Okay, so now with that, you will need to do activity number 30. Activity number 30 from number 1 to number 3. Activity number 30 from number 1 to number 3, not forgetting activity number 29. So at the end of this lesson, you should have done 2 activities, which is activity number 29 and activity number 30. Okay, all the best as you are doing these activities. Super.